So I want to talk about our infrastructure team, some challenges and some fun stories which we've had over the years. So first, let me introduce myself. This is my Slack profile. My name is Jan. Everybody calls me Juzna. And my official title here at kiwi.com is Head of Infrastructure, which I got after about 2 years in the company. And the second part is my unofficial title, which is Head of Yoga, which I actually gave myself in the first week when I joined. Because this is a fun fact, I'm also a yoga teacher, and I'm teaching yoga classes at the office. Unfortunately, not anymore because COVID, but before that, I was teaching 2 classes per week at the office gym, which I think is an amazing perk and amazing thing what we can do here at Kiwi, that just this is possible, and I like it. So if you want to do something else than just work, you can of course do it at the office as well and find people who are interested in that. But let's jump to the talk, and I will start what is even infrastructure team like? So we have 20 people taking care of our infrastructure. But you might ask, why do you need 20 people to do this? Isn't there this thing called cloud or serverless, which is basically doing all the infrastructure for you so that you don't have to care about it and just use the services, write code, ship it, and deploy it, and then it runs? And the answer is yes, but well, it's not that easy. There's lots of cloud providers, too many services, too many options. It would be a huge mess if every team would use whatever they choose. We have in the company about 500 people in engineering and about maybe more than 100 microservices. If we need all of that, and why do we have so many, that's a different topic, which I will not go into, but that's the case. And we need to have some sensible defaults across all of them. So also we want to make it easy for all the teams so they just don't go crazy of basically picking from so many options and not knowing what to choose. So we as infrastructure team, we are basically opinionated cloud provider. We pick and choose from all the offerings which there are, and then we give it to our dev teams. And so I'll go back. We are 20 people taking care of our infrastructure, which means we provide basically platform as a service to all our dev teams, which is unified, which is easy for them to use, so that they don't have to decide and they know that they are using what they should be using. We also provide the best practices for all the teams. So we tell them how to set up monitoring, what are the best thresholds, how to best set up all of that. We write wikis, we do training for them. And we try to make the whole engineering department to be easy and similar to each other so that people can jump to another team and understand what's happening there. We also help teams with designing their solutions. So if a team comes to us and they say we have this amount of data somewhere, we need to do some processing, what's the best way to handle it? So we sit with them, we look at the problem, we try to understand it, and we try to design it with them to make sure that the developers also have the infrastructure in mind, they know how it works, and they know the possible problems, they know what to focus on. This improves then the reliability of the services, scalability, and of course, efficiency as well, because we don't want to just pay too much for anything if there is a simple and much cheaper way to do it. We also provide support to all the development teams, which means on Slack, if there are any questions or any help which developers need with the infrastructure and they are not sure about it because they want to focus on writing the code and not that much on the infrastructure, we help them. And we also have PagerDuty. If there is some big problem and they need help at any point, then can page us, wake us up during the night, and we'll help them figure out if there's a problem with the infrastructure or with something, and how we can fix it. And then we also provide lots of basic services which all the other teams need, and which may not be provided by the cloud providers, or maybe we decided not to use like the cloud service, but we decided to run our own, like, for example, if it's open source. So for example, we use HashiCorp Vault for storing secrets, which is open source. We run it, and then we provide it to the rest of the company as software as a service, like any other cloud. So nobody needs to care like how it works. They just have an endpoint, talk to it, and that's it. We provide Scala database to the teams. Then we have a Rancher, which is like Kubernetes set up on bare metal machines, because we don't have everything running in the public Google Cloud or AWS. Or Istio, Kafka, GitLab, and many more, which we decided we want to run ourselves. The devs wanted, like multiple teams need it. So we just said like, okay, let's provide it basically as another service, which anybody in the company can use. And they don't have to care about maintenance, security, updates, anything else. And we also push new company-wide tech standards. So for example, we decided as the whole company that we should migrate to Google Cloud from AWS. So our team was responsible for the migration, and we were pushing it. We were doing basically all on the top to make this happen. Another thing would be Cloudflare. Again, like we pushed, or we are pushing to use Cloudflare, Istio, Datadog, and many more. So let me jump to an example, like of one of the things what we do, to give you a bit more detail, because this is very broad and generic, so it may be hard to imagine. And that's Datadog. If you don't know Datadog, it's an amazing monitoring tool. It has lots of features, great integrations. We love it. We use it for everything we can. And it gives us great visibility into what we are doing and how all our services work. We've been using that for many, many years. They just keep adding more and more features, and then we try to integrate those features and use them. And then, as I said before, push it to all the dev teams to use that. In 2019, Datadog added logs feature, so that basically you could ship logs from your applications to Datadog and monitor it there. At the time, as almost everybody in the industry, were using Elk Stack, which is Elasticsearch, Logstash, Kibana, which probably you know. And we had different setups. Some teams set it up on their own, and it was like going old. It wasn't really great. It wasn't evolving as fast as we wanted, and there was lots of maintenance for us. We were also using Logs.io service, which is basically managed Elk or managed Elasticsearch and Kibana. But then we had a problem there that it was like one service for logs, and then we had all the rest of monitoring in Datadog. So we looked at the options, we talked to Datadog, we decided that the logs feature in Datadog is good enough. And we basically decided, let's take all the logs we have in the company in all the 100 microservices, and let's ship them to Datadog and use that. To give us the benefit that we can like combine the metrics, logs, and other monitoring data in one dashboard, in one alert, etc. So that looks simpler, right? We just take Datadog, install it, configure it, then done, right? Doesn't look that hard. The complication is we have tens of Kubernetes clusters because so many teams. At the time, we had lots of Rancher 1 clusters. We had lots of services running on EC2, just VMs without that. So like lots of diversity. So not that simple. And also we need to update all the services to use this. So our team's goal was to basically figure out what's the best way to make this migration happen. So the trivial solution would be, let's just install the Datadog agents, which collect the data and logs everywhere. Maybe some copy pasting, but it's not great. It wouldn't be maintainable, and like it would work, but in a month the situation will be horrible. So instead of, we decided to use customize as the first step, which basically you can define some base application for Kubernetes. And then in each cluster, you just reference the base, add some overrides or overlays for only the things which differ in each cluster. And then you can deploy it. And it's easier to manage because you only have basically the base. When you need to make any changes, you just update the base. And then you go to each cluster, just reapply it, and that's done. So we did this. It was like the MVP, basically. It worked pretty well. But then we thought, okay, we need to improve this because if we want to upgrade Datadog, if Datadog releases a new version of the agent, it's not that easy to upgrade it for us. So we said, okay, next step, let's use Helm, which is again for Kubernetes, like how to distribute the manifests and packages. So integrated that. And then we merged everything into CI/CD. So now we have a cron, and when we, if there's a new version of Datadog, we still want to be a little bit involved. So we get a message on Slack which says there's a new Datadog upgrade available. Do you want to do it? It sends us a link to a merge request, which is automatically created. And if we can look at it, we can decide, we can check the change log, decide if it's safe, and then we can just merge it, run apply, and the automation will basically, this is from GitLab CI, if you know that. If not, this is running the automation, and it basically finds all the places where Datadog agent is installed and applies the new version there. So now for us, when there's a new version of Datadog agent, we get the message from Slack, we check it, we maybe post it to teams to notify them there's an upgrade, and then we hit one button and installed everywhere. So very little maintenance and automation. Maybe in the future, if we are sure, we could probably automate it completely and new versions would be just deployed completely automatically. So that's like the next step which we want to do. And this is basically what we do for all the services. This was one example what we try to apply this for anything. Let me jump to another topic, which is war stories and some fun. So I will first start with a spoiler. Maybe if you know what this is a data center. This was the news articles the following morning, because this happened during night. Millions of the websites offline after fire at French cloud services firm. So how does it relate to us? It relates this way. We have a Scala database, our main database for searches, and we have Rancher clusters with some, like, there's mainly search and some other services running or were running in this data center. So not great, right? If this happens. Actually, this happened during the night. It was just a normal day. People went to sleep. Then about 1 a.m., we started receiving some alerts only on Slack because it was like one server is down and unreachable. So we only send it to Slack, not to PagerDuty, because if people don't see it, we don't need to wake them up for one server. Everything should work. Then we started getting more and more servers were dying in this, and we still didn't know that there's a fire, or we still didn't know what's happening. And then we got a PagerDuty alert that like there's too many servers down in one data center. Maybe like some human should check what's happening and if there's caused by us or we can fix it. We looked into it. We didn't have much to do, but everything else was working fine, like all the services. Scala, by the way, is replicated in 3 data centers. So it was fine. Then we got a page from the search devs that they saw that like they were getting increased errors and increased latency. You can see on some of these graphs. So when it was happening at 1 a.m. Nice. Let me try to use a laser pointer. So this is where it happened. This is the load. It increased a bit and went back to normal. Requests by server just went up on the other data centers, and the affected data center on fire just disappeared. there were some errors, some increased latency. So we got pinged by the search team, and we got paged by them and asked like, is there some problem? We just said, yeah, there's a problem. The data center is not responding. We actually didn't know at the time that there's a fire, but everything works fine. So we'll just leave it as it is, and we'll check again in the morning, and people go back to sleep. And that was pretty much it. In the morning, we woke up, we found out that there was the fire, but service is working. People still could search, people still could book everything. Basically, customers didn't notice. There were a couple of internal services which had some problems, but nothing really visible to the outside. Funny graph is CPU temperature. You can clearly see like which servers were in the affected data center as the CPU temperature just rose. What we did after the outage, we wrote a postmortem to explain to the whole engineering what happened, why it happened, what was good, what was bad, etc., what we could fix to make it even better. So in each postmortem, we write what was the good part. And the good part was actually we planned for this. We designed the services with this in mind, so customers wouldn't notice and everything were fine. So this was great. Obviously, not everything was great. So we had bad parts that some services were not configured that great, and some internal services were down. So we mentioned it in postmortem, and we discussed things like what we can improve in the future so that if there's next data center fire, it will be even better. And we also mentioned like the lucky part in each postmortem. So we got lucky in that part that our disaster recovery got tested. Finally, we never found time to do that. And here we found it. So we did that. And we also managed, there's a message, there's a good thing that there were old servers which got destroyed and we got new servers instead. So this is a nice thing as well. And I'm running out of time, so I will, yeah, if you want to know more, you can find more at our blog at code.kiwi.com. I will skip this part, and of course, we're hiring. So we have open positions in all our offices and possibly even more, so just ask the recruiter. We're looking for any infra engineers, or could be called system engineers or DevOps engineers. So you can find more at jobs.kiwi.com. And that's it from me. You can reach me at this email or at Twitter.